Hello engineers, welcome to 14th lecture of ASME BPVC Section 8 Division 1 Code Training. So that is today we will discuss basics of vessels, that is what is a vessel, for what purpose we are using the vessels, what are the shapes generally uh, industries used for these vessels. So all we discuss in this lecture. So generally the vessels are used for storing fluids under pressure, and the vessel which is used for boilers, compressed air receivers are generally in the shape of cylindrical and spherical forms. Why? Most industries use cylindrical and spherical forms because for these shapes, the generation of stress, so stresses which are generated due to pressure is very less compared to other shape guys. So that's why most of the industries prefer cylindrical and spherical forms compared to other shapes like rectangle and other shapes. So compared to the vessel thickness, so vessel diameter is more. So based upon this thickness ratio only, we compare whether the vessel is a thin vessel or thick vessel. So if our thickness is less than diameter by 20, then the vessel is said to be a thin vessel. If the thickness is greater than d by 20, so then the vessel is said to be thick vessel. So this all are information we already known in our engineering classes only. So let's discuss what are the stresses induced due to pressure in the cylindrical vessels, guys. So generally there are three types of stresses induced due to this pressure. So one is circumferential stress, and the next one is longitudinal stress and radial stress. So let's discuss one by one, guys. So first one is circumferential stress. So here I am showing the circumferential acting area. So circumferential stress acts on this area. Here you are already seeing this. So I'm highlighting this section. So this is the section where circumferential generally focusing. Okay. So we know circumferential stress is also known as hoop stress. So stress is equal to force by area. It is the general formula. So let's find area, guys. So this is the area. This is the area where circumferential stress acting. So area is equal to length into width, right? So length L. So what is our here width? It is the thickness, but it acting in two areas, right? Two sections. That is here thickness T and here thickness T, but length is common. So area is equal to L into two times of thickness. These two are one term, and this L is one term, guys. So these two not applicable to L. These two applicable for T only. So L into 2T. Okay. Next one is force. So we know pressure is equal to force by area, right? So now force is equal to pressure into area. So where pressure is acting on this area only. So it is round, right? It is round. So force is equal to pressure into area. Area, what is this area? D into, so here you can see pressure. So area, this is area. D into throughout this length. Okay. I hope you understand these two formulas. So now we can divide the both. So PdL by LT into 2, right? So if we cancel this L and this L, so we have PD by 2T. So this is the formula for circumferential stresses which are you induced in a cylindrical vessel. This formula is for cylindrical vessel, guys. Okay. So next one is longitudinal stress. So longitudinal stress area, this is the where longitudinal stress generally acting area, right? So I'm here highlighting. So for your reference purpose, here I also mentioned one image. So before going to derive the longitudinal stresses, if you are new to my channel, welcome to Mechanical Training World channel. So subscribe my channel for more interesting videos will come in the future. So you will get notified. So please share to your friends. They will also get benefited with these videos. So let's continue our session, guys. So we know longitudinal stress is equal to force by area. So area is equal to P in pi d into T. So generally longitudinal stress focusing on this area, right? So this is the area. So if we cut this, it will like a plate, right? So this is pi d. This is our pi d. So and this is our thickness. So area is equal to pi d into thickness, guys. So I hope you understand. And force is equal to pressure into area. On what area? This is the area, right? Generally pressure acting on this area. So like this, right? So it is a circle form. So that's why pi d square by 4. So I hope these two formulas you understand, I think. So if we divide both the formulas, we will get so d square and d cancel. So this pi and this pi cancel. So finally we have longitudinal stress is equal to PD by 40. So And next one is radial stress. So generally radial stress exerts on the direction of the radius. So this is the radial stress, guys. So if it exerts on this radius section. So like this radial stress acting. So and the pressure is also acting like this only. So radial stress acting like this and the pressure is also acting on the same direction. So both the areas are same. So the radial stress, whatever the radial stress acting on this is equal to pressure. So I hope you understand this formula. Which stress is governing our design, guys? So we need to know, right? Which stress is governing mainly our design. So let's see. We know sigma r is equal to P. So this is definitely not a governing stress. So apart from this, we have circumferential and longitudinal stress. For thin cylinders, hoop stress is equal to PD by 2T and longitudinal stress is equal to PD by 40. If we divide both the stresses, we will get, so if we divide this, both the stresses PD by 2T, PD by 40, right? Sigma L by sigma H, PD by 2T. That's right, right? So PD cancel, this T cancel, this 2 in this 2 times. So we have finally 1 by 2, guys. So sigma L by sigma H is equal to 1 by 2. So that is longitudinal stress is half of the circumferential stress, right? So circumferential stress is equal to 2 times the longitudinal stress. So here our governing factor is circumferential stress. So I hope you understand this session. So thank you, guys.